So when it says find the product, it means it means simplify it, right?
Yeah, so like you've got two monomials there, right? You've got 2a squared b, that's one. You've got 1/2 b, that's another monomial. And then you've got a binomial. So find the product means do your multiplication, right? So maybe, which I would simplify things. It would combine things. So maybe you would multiply these two first, right? This is kind of like our really huge polynomial multiplication problem that we did last class. But instead of having 6 monomials, we just have the 2 here.
Right.
Yeah. Folks, it is 9 o'clock, so we'll have 5 more minutes working on this. But I would like to say to everyone, oh, yeah, will this be a G? Oh, you know what I'm spelling. You know what I'm going to say? I'm going to say good morning with 2 exclamation points. It's good to see you. Welcome to class. I hope you had a good weekend. Is there anyone who has anything to share from their weekend?
Well, it's not from my weekend, but today is actually my birthday. So.
Well, happy birthday, Krista.
Happy birthday, Krista!
Do you have any big like birthday plans, or like today? Do you have like no? Do you usually do anything special for your birthdays, or?
Yeah, usually, but this year my parents just kind of flaked. So.
Well, I bet you. I wouldn't be surprised if they have maybe something planned, but maybe you don't know what it is. Well, cool. Congratulations. It's always exciting to have your birthday. Awesome. Anyone else? Any stories from their weekend? All right. I hung out with my friends, not all of them at once, but I have a couple of friends who they have a dog, and this is a dog that they rescued, and he's very cute. He's very friendly, and he's cute too because he's kind of like he's a bit of a mutt. Like he's got a little bit of everything. But he's got kind of short legs. He's a big dog, but he has kind of short legs. But he was very. When we were hanging out, he was very flatulent, if you know what I mean. Like he was passing gas quite a bit, and it was very it was pretty smelly. Like I don't know if I've ever smelled dog farts that smelled so bad, but yeah, it was. Besides that, it was. I mean that was fine, but yeah, it was good to see our friends that day. All right, let's talk a little bit about this challenge question here, and then maybe we'll be close to time to begin today's lesson. So yeah, this is very similar to the huge question that we did last class, where we had 6 monomials. We had lots of monomials. Excuse me. We had lots of monomials, multiplied them together. My suggestion with that one was to start by multiplying the monomials. We notice that we have a binomial here in underlined in blue. And my suggestion is to leave that until the very end. So if we multiply this stuff in between here, or in red, we see that we would go 2 times 1/2, which, if we do that work over here, that's like 2/1 times 1/2. Oh, that's like 2/2, which, hey, that just cancels out and equals 1. So we might have a 1, and then we go a squared. Well, there's no a in this second one here, so it's just going to stay a squared. And then there's a b times a b, which becomes a b squared. So that one we don't need. I'm going to move that bracket. And the thing that has a red square around it here simplifies to something quite nice. It's just a squared b squared. And then our binomial here, 5a minus 7b, well, we remember that when we have a monomial multiplied by a binomial, we're going to do distribution. So let's say that instead I had something like this, a squared b times 2a squared plus 3a b. Let's say we had that. Well, I'm going to go a squared times 2a, which becomes simply 2a to the power of 4, right? We go a squared times a squared is a to the power of 4. Don't forget that b there. Then I'm going to go a squared b times 3ab, and that becomes, well, it's a plus. It's 3a cubed b squared. And that would be my final answer. Note that this is a different question, right? I'm not going to show you the rest of the answers here, but it would follow along like this, kind of. All right. Any questions about that? All right. Let's take just one more minute or so. I'll finish up attendance for now, and then we'll keep going. All right. Krista, Matthias, Noah, Rachel, Raquel, and Ruben. Ruben, is Jonah there today as well?
You should be. He's
Oh,
in the other room. I think he's
see.
there.
Okay.
Oh, stupid.
Sorry, I just realized, Jonah, I see a Ruben Broadway and a Ruben Broadway, all one word. So no, that's okay. I see both of you there.
It automatically puts my name to Ruben Broadway for some reason, so I always forget to change it.
Okay, no problem. All right, so folks, let's continue. Let's move on to today's lesson here. I think first of all, was it this class that that produced this wonderful piece of art, or was it the Math 10Bs? I think it was the Math 10Bs, maybe. But I know we have I know we have a little bit of overlap here and there. That's a beautiful piece of art that the class collaborated on together. All right, moving on from the art gallery. Today we're talking about multiplying polynomials, and in particular, we are multiplying a binomial with a binomial. So, for example, we did. Rachel says, "Yeah." Oh, that was us. Okay, good. So there were a few people there, and it was a beautiful piece of art that we tried to compete for. Students were competing for who would take home that piece of art. Unfortunately, nobody won it. So for now, it's hanging up in the art gallery, and that's the only place you can view it. All right. So what we have done is monomials with binomials, right? So that's when we have just one thing multiplied, or one term multiplied by 2, right? We realize we do this distribution thing. And we've done, of course, monomials with monomials. We don't have to do any sort of distribution with that. But binomials with binomials, we're going to look at 4 methods today. It's a little overkill, but that's how many are in your textbook. And it's when you've got 2 terms multiplied by another 2 terms. And in fact, we'll also move on to binomials with trinomials. Binomials with trinomials we don't encounter as much, but it's good to go over. All right. And starting off, we're going to talk about how finding the area of a rectangle in particular is like an analogy. So it helps us with multiplying. It helps us visualize helps us visualize multiplying. All right. So let's say that we have a square, or sorry, not a square. This is a rectangle. It clearly says right there. And I'm saying that rectangles can act like a model for multiplication. Of course, the area of any rectangle can be found by going length times width. And we see that if we plug in our length of 5 and our width of 8, we can see that all we're doing is multiplication, okay? And so even without writing it down over here, if this was obscured over here, we can look at our rectangle on the left here, and we can see that and maybe recognize it as a type of multiplication. We're going to multiply the 5 by the 8, all right, to get our answer, which of course in this case is 40. Right? Now this holds true as well if instead of just whole numbers, I had something like 8x times 5x, right? That would mean that our length is 5x and our width is 8x. And what this means is that our x, we recognize these x's as variables. They can be things numbers that can change, or just numbers that are unknown. And so what this might mean is that there's some relationship between these lengths, but we don't know exactly what they are. Okay, so this kind of means that they're locked into this kind of relationship. X might be 1 or X might be 2 or something in between. But they are important parts of the length and the width. And so that would mean that our area here, well, we're going to do 40 and then x squared, right? So 40 times x squared. That's our area. All right. And so, we can, if we had this and someone said, okay, actually, I know what x is equal to 2. And if we were asked to find the area, we would then have a couple of ways to do that, right? First of all, we could figure out that if we're talking about 8x, that's going to be 8 times 2, or 16. Likewise, over here, 5x becomes 5 times 2, or 10. And so we can see that then at that point, if we're doing our calculations with length and width, we're going to have 10 times 16, or 160. Right? So that would be one way of finding our area. Or we could take our area here that we had found. We're going to go area equals 40. And then in our bracket here, we're saying that our x is 2. Sorry, that's a little mismatched color. 2 squared. So that's going to be 40 times, well, 2 squared is 4. And 40 times 4 is 160. Right? So we've calculated it 2 ways. Anyway, the point of this is that we can use calculating the area of a rectangle to visualize multiplication. So let's move on. What about a rectangle that has a length of 5 and a width of 8 plus 3? And so I'm trying to show here that our one number length is like a monomial, and our 8 plus 3, our 2 numbers here, is like a binomial. And so, of course, if we have a length of 5 and a width of 8 plus 3, one thing we could do is simply like update this. We could say 8 plus 3 is 11. And so our area is 5 by 11, or 55. Of course, we can do that. No problem, right? But let's back up. Let's see what we can learn by keeping this 8 plus 3 as in 2 separate terms. So let's say that 8, if we counted that all up, this would be a width of 11. But let's say that we kind of split it up into its 2 parts, right? So let's just erase this a little bit. So here we have, I'll use some different colors. Here we have our 8, right? This is our length of 8 from here to here, right? That's our length of 8. And then here we have our length of 3, right? From here to here. That scale is not quite right, but let's just say that's okay. Well, now I can split this right down here. And now I've got 2 rectangles there, right? I've got a 5 by 8 rectangle, 5 by 8 rectangle. So we can do our area calculation here. That's going to be 5 times 8, that's 40, right? And over here, I've got a 5 by 3. So that's 5 times 3, or 15, right? And we can see that the total area then is going to be the sum of those. It's going to be, the total area is going to be 40 plus 15. Okay, and this is interesting because this is an analogy for this kind of stuff, which we have done already. We've done something that looks like this. This is where we end up using our distribution. If we have an area that's 5 times 8 plus 3, so this is like our width times our length, we end up doing, well, 5 times 8 is 40, right? So we do 5 times 8 is 40, 5 times 3 is 15, which looks exactly like this, and we end up with 55.
Isn't that like a really difficult way of doing it? Couldn't you just add 8 and 3 together?
Sure, you're right. This is a difficult way of doing this. Isn't it easier to just add 8 and 3 together? Yes, you're right. But you know what happens, and you know why you're right. This is difficult. The reason that we're looking at this is because, hey, what if instead of 8 plus 3, which of course we can combine, what if we had 8x plus 3? That is something that you cannot combine. You can't put 8x and 3 together to make 11, right? They got to stay like that. And so if we do that, we have to use distribution like this, right? And we don't get this 55. We end with 40x plus 15. So we're just learning a lesson here as we go. We can use this distribution and we can visualize it like a rectangle. All right, what do you think is on the next slide? We've done based on what we saw on the previous slide, on this slide, what do you think is next? Any guesses? Anyone? I'll give you a hint, it's another rectangle, but it's not going to be a monomial by a binomial. It's going to be 2 binomials. All right, and that's kind of the point of today's lesson, is that we're moving on to binomials times binomials. And that's what we see here. And we want to, let's just visualize what that might look like. All right. So we've got 5 plus 4 and a width of 8 plus 3. So our width, we're kind of breaking it down on that same spot right here. So that's our 5 and our, that's our 8 and our 3, and I'll use different colors. Our 8 and our 3. And over on this side, we've got 2 as well. So that's going to get split up there. And this is split, that's 8 and 3. This is split along 5 and 4. And yeah, my scale is just okay. So this is 5 and 4. All right. Notice if we do it this way, like, okay, yes, of course, we can just do, hey, this is going to be 9, this is going to be 11, area is going to be 99. That's too easy. That's too easy. We don't want to do things, no, we usually do want to pick the easiest way. But for this, we're learning something. All right, so here we have this area. What is this area of this rectangle here? So sorry, we're going to calculate the area of all 4 of these rectangles. What's the area of this one down here?
40.
40. We did that one before. That's 5 times 8 is 40. Over here, we're doing 5 times 3. That's 15. Okay. Up here, we're doing 8 times 4. That's 32. And over here, we're doing 4 times 3 is 12. We already said we did the calculation. This is 9 times 11. This is 99. So all these added up should be equal to 99. And in fact, they are. I betcha. I'm not certain. Let's see. 40 plus 15 plus 32 plus 12. Oh, yeah. 99. All right. And so what this is showing, what this can show is that if we have our 2 binomials that we're multiplying together, if we've got our 2 binomials here, we've got 8 plus 3, 8, 3, we've got our 5, and we've got our 4. We can see that what we end up doing is one of our areas, this one here, one of our areas is 5 times 4. So, or sorry, 5 times 8. So we're doing this multiplication here, right? 8 times 5 is 40, okay? One of our multiplications is this 8 times 5. Right, this one here, 8 times 4. So it's 8 times 4. That's 32. One of them is our 3 times 5. That's this one. 3 times 5. So I'm multiplying this here. Okay, that's 15. And then the last one is 3 times 4. So that's going from here to here. Okay, and that's 12. Okay. And so what we're visualizing here is distribution, but instead of just a monomial with a binomial, it's binomial with binomial. And we have to, each term from this first binomial has to multiply with each term from the other. So what we end up doing is something that I see many people call the rainbow method. You see, we're kind of creating a rainbow here, right? We've got, let's do this. We've got 8 times 5, that's part of the rainbow. 8 times 4 is part of the rainbow. 3 times 5 is part of the rainbow, and 3 times 4 is part of the rainbow, right? So some people call it the rainbow method. I like to call it FOIL. FOIL, because that tells us what we're multiplying, right? So we go the first one from the first binomial and the first one from the second binomial. So that stands for firsts. We multiply our firsts together. We go the first one times the last one. So those are the outsides, right? This is outsides, outsides. Then we do 3 times 5, those are the ones that are the 2 ones that are closest to the insides. So that's insides. And finally, L. What does a L stand for?
Last.
Yep. Yep. L is last. And so this is a little, what do they call that? It's not an acronym, but it's like, I forget. But anyway, it's a little word that helps us remember.
You're right. It is an acronym.
It's an acronym, okay, because we've got
Yeah.
the letters in a row and they're standing for something. So it's something that helps us remember, okay, we have to do these multiplications, all right? Are there any questions so far? Are you guys sick of rectangles yet? Enough with the rectangles. Look, we got 4 rectangles on one slide. We did 2 rectangles on the last one. Are we done with rectangles yet? I think we are for now. Yep, I'm sick of them. Rachel doesn't want to see another rectangle for the rest of her life. Sorry, Rachel, you might see some around you. Actually, there's a big rectangle behind you. That's a big old window, isn't it? The rectangular window, maybe? Sorry. All right. We can also, sorry, we certainly will see some more rectangles, I'm sorry. So things like this, example 1, model x times 2x plus 3. We can model that with a rectangle. So we can have our x here. We've got a 2x plus 3, right? And so we realize that our area here, this little bit, is going to become 2x squared, and our area here is going to become 3x. We can see that our total area is 2x squared plus 3x. And that's the same thing if we had done distribution. And the next one, let's say we modeled the next one here. This is x plus 3 times x plus 1, right? So we see that we can do another rectangle. Let's say we've got x. It's kind of ugly. That's okay. Let's say we've got x plus 3 on that side, and we've got x plus 1 over here. Maybe my lengths don't quite make sense, but that's okay. So this is going to be x times x is x squared. Up here, we see that this rectangle is going to have this width of x and this height of 3, so this becomes 3x. Likewise, this is 1 by x. This is just x. And then this one here has a width of 1, height of 3. This is just 3. So what we end up with is x squared plus 3x plus x plus 3. However, we can combine these two together, 3x plus x. We get 4x. Okay. And that would be the same thing if we did our FOIL method that we are just learning about today. All right, we can also use algebra tiles for this. So let's have a look. We had, one of them was x plus 1 times x plus 3. So we've got width, or we've got a height, let's say, of x plus 1. And over here, we've got x plus 3. 1, 2, 3. Can you guys see that okay? Here, I'm going to zoom in. All right, so we've got x plus 1 up here, x plus 3 over here. Algebra tiles. Have you guys used algebra tiles before? Yeah, maybe a little bit. I feel like algebra tiles just a few short years ago was really big in the curriculum, and the BC curriculum, like BC Education, really wanted students to learn algebra tiles. The emphasis is off of it now, but it's still a helpful analogy. So here we can see that we've got a x by x, that's going to make an x squared, right? We kind of just put things in so that they line up, right? This is going to be x by 1. I think this one I'm going to have to rotate. There it goes. I'm going to rotate this one. There it goes. And this one here. And then we can fill in the 1, 1, 1 here. So we see that we've filled it in exactly. We've got this length of x plus 1. This is x plus 3. And by doing that, we have, what do we got? We have 1 x squared. We have 1, 2, 3, 4 x's. And we have 1 Sorry, we have 3 1s, right? And so algebra tiles can help us visualize that. All right, nice work. Any questions? You guys are doing good. No questions. Okay. Yes, questions? Okay. Great, good. In your textbook, there are 4 methods of multiplying binomials with binomials. We'll go through a couple of them kind of quickly, and then we'll some others we'll spend some more time on. So we're going to look at page 71 to 74. I'm saying that each of these 4 methods helps us keep track of the different parts that need to be multiplied together. Decide which method you like the best. We're going to start actually with method 4. So that's page 74, and then we're going to work our way backwards. So turn to page 74. It looks like this. Rachel, look. More rectangles. All right, page 74. Does everyone have it? Does everyone have it in front of them? The more rectangles page 74. So have a look. I know this might seem weird that we're going backwards here, but have a look. What we're doing is very familiar. We're multiplying. We've got a binomial here multiplied by another binomial. And we've done a little drawing here where we have rectangles within rectangles. We've separated our 3x plus 2 to look like 3x is the length between here and here. And then 2 is the length between here and here, right? And so this, what your textbook is doing here is labeling each of these rectangles 1, 2, 3, and 4, these Roman numerals. We're saying, of course, that the total area is just going to be the area of each of those rectangles put together. And that first rectangle is going to be 2x times 3x, right? That's this times this, and so on. So putting that all together, we end up with this trinomial here, 6x squared plus 7x. And by now, this is something that we looked at in a couple of other examples as well. We can see that this even helps us multiply a trinomial by a binomial. It helps us keep track of all the multiplication that we're doing, right? Because we can label all these rectangles as 1, 2, 3, 4, 5, 6. We know if we wanted to find the total area, it would be all of those put together, and your textbook is doing all that multiplication. Any questions or anything on this page? Yes, Krista.
Just to clarify though, if it doesn't matter what order you add the areas in, right?
You're right. It does not matter. So someone else might start here and then do this one, then this one, then this one. It doesn't make any sense, but like, yeah. So it doesn't matter. What is preferred? Notice at the end that we have our polynomial written in the way that we like. We're starting with the highest degree and working our way down. Yeah. All right. So that is method 4. That's what your textbook is calling method 4. Let's go the page just before it. Okay. This is the method that I grew up with. I'm familiar with this, and I really like this. Is FOIL. It's an acronym that stands for first, outside, inside, and last. And so we've got this little arrow thing. In the diagram below, first refers to A times C, right? So the first one from that binomial multiplied by the first one there. Outside refers to A times D, that times that. Inside refers to B times C, that times that. And last refers to B times D. So we can use that to multiply 2x minus 3 times 3x plus 1. And I'll just kind of zoom in there and we'll too close. No, that's good. So first we'll go 2x times 3x becomes 6x squared. Let's make this a rainbow. Oh, okay, hold on. Let's start over. Start with red, right? 2x times 3x equals 6x squared. Let's do orange. 2x times 1 becomes 2x. Let's do green. Negative 3 times 3x becomes minus 9x. And then we'll do violet. Here we go. Negative 3 times 1 becomes a minus 3. So putting those all together, we get our 6x squared. We can combine these two terms. 2x minus 9x. We've got orange and green. What happens when you mix orange and green? What color? Is it just like brown? So that's going to be minus 7x. It's a brown. I don't know if you can really see that. Minus 7x. And then we've got our violet here at the end. Minus 3. Right? So you see how that helped us multiply. Okay. Let's see. It's 9:36. What I would like you folks to do, just for like 10 minutes or less, okay, 10 minutes or less, I want you to practice a multiplication, all right? So let's see, do I have one? No, I don't. But let's say we've got this multiplication here. We are multiplying binomials. We're gonna do let's say 5x plus 3 and 3x minus 2. Okay, I want you to practice that. And so if someone can write this down, I'm going to split you off into groups. What I want you to do is show me a rectangle, like do it using rectangular method, and then I want you to show me with the FOIL method. And so when you're in your group, someone should open up a whiteboard and just show those two methods. And I'm just going to jump from room to room. I don't think this will take long. And then after this, we'll take our break. Okay? Any questions about that? All right. There we go. Folks, let's keep going here. We have most folks are back. Yeah, let's keep going. So we were looking at our 4 different methods, and we stopped on the what we're calling, they are calling the horizontal method. I call the FOIL method. And they've got example 7 here, where again we see this what is not being shown is our rainbow, right? So we're going 2x times 3x. That's the multiplication here. We're going 2x times 1. That's our multiplication here. We're going negative 3 times 3x and negative 3 times 4. And that helps us keep track of all these bits that we have to multiply. After we do that multiplication, we end up with this, and we can combine only two of them. These two are the ones that have like terms. They're both x terms, so they can be added together. And we're done. There's a note about how the acronym FOIL does not work since we have more than just outsides, insides, first and last. But the method is still kind of the same, right? We look at, we'll start with the 3x here, and we'll multiply by that first one, then this middle one, and then this last one. And that's the work that we're doing here, here, and here, right? And then we'll do this one times our second one here. 2 kind of becomes the star. We go 2 times x squared, 2 times negative 7x, and 2 times 5. And that's what is right here. All right. There's more that we can combine here. This maybe looks a little more confusing, but we can combine this with this, and we can combine this with this to form our final answer down here. Any questions so far? All right.
So,
yeah.
You pretty much, a simpler way of doing that is just to say that you times the first one by all 3 in the second in the trinomial, and then the second part of the binomial to all 3 of the trinomial.
Yeah, that's right. Exactly. So that's another way of saying it. And then we just remember that what we do with those all those different things is we, add them together. Add or subtract depending on if you've got positives or negatives. Yeah, exactly. All right, I want to jump back to, I know this is a little weird jumping around a bit, but let's look at method 1, distributive method. And I just want to illustrate that this is very similar to FOIL, except that like it's just broken down, right? It's organized slightly differently. So if we have, again, we're looking at the same binomial. I don't know if you notice that, but every time we're looking at the same binomial times binomial, what we're doing, we keep that first binomial the same, and we break up, we split up the second one. So we're breaking up this x plus 2 into just the x here and the 2 here. And then once we're at this point, we just rely on our normal distribution, right? So we're going to go x times 2x gives us 2x squared, and then x times negative 3 gives us negative 3x. And then we do the same thing over here. We're going 2 times 2x gives us 4x, and 2 times negative 3 gives us negative 6. Putting it all together, we get that, right? We're combining our 2 like terms. All right. So slightly different way of writing it out, slightly different way of thinking about it, but very similar. And we can see that we can do that with larger things as well, right? It helps us keep this organized. What your textbook is doing is splitting up each of these 3 things, each of this trinomial into its 3 parts, right? We see this here, we see this here, and we see this here. Okay. Okay, and then our last method that we're going to look at is interesting. I like this one, but this is one that I never used when I was growing up. I think it might seem really complicated, but it's not too bad. So we're multiplying a trinomial by a binomial, and it's set up a lot like a multiplication, right? Just like if we had 40 times, let's do something a little more complex, right? Let's say you had 437 times 21. If you remember doing this kind of work without a calculator, you can line things up like this, right? And we go 1 times 7 is 7, 1 times 3 is 3, 1 times 4 is 4. We add a 0 here, and we do 2 times 7 is 14. We carry up that 1. 2 times 3 is 6 plus 1 is 7, and 2 times 4 is 8. You remember doing this kind of stuff? Yeah. And then we add them, right? So 7 plus 0 is 7, 3 plus 4 is 7, 4 plus 7 is 11, carry the 1, 1 plus 8 is 9, and that's our answer. This over here is a lot like that. It's very analogous to that, right? Let's take a look. You know, on our multiplication over here, we started with our ones, right? We started with our 1, and we multiplied this by each term here. Same with over here. We're starting with our smallest one, our 5, and we multiply it by each term up here. So we're going negative, negative 5 times negative 3 is 15. And negative 5 times negative 5x is positive 25x. Negative 5 times 3x squared gives us negative 15x squared. You see that? That's kind of interesting. And then we leave a little bit of gap below that, right? We got a gap there. And we go 2x times negative 3. We're going to do 2x multiplied by each of our things here. 2x times negative 3 gives us negative 6x. 2x times negative 5x gives us negative 10x squared. And 2x times 3x squared gives us 6x cubed. Notice that now these are all lined up. This might not happen every time, but they're lined up with what can combine, right? So we can go 15. 15 plus like an invisible 0 is just 15. 25x plus negative 6x gives us 19x. Oops. 15x squared, negative 15x squared minus 10x squared gives us negative 25x squared. And then 6x cubed is just by itself. And so this is our final answer. That's kind of neat, I think, right? I like that. I like that it also builds on something we learned when, you know, in grade 5 maybe? Yeah. It's just multiplying. Yeah, it's just multiplying. You folks said that just seems confusing to me. You must be talking about this one. It is a little confusing, right? And so I told you guys we were going to learn 4 methods, and I want you to choose the one that you like the best. For me, that's FOIL, right? FOIL just helps me keep track of things. But for you, it might be this one here, or the rectangles. You're going to be drawing rectangles for the rest of the year, you know, not the rest of the year, but yeah. This last one here, notice that what they're suggesting is to rewrite the polynomial in descending order of powers. And just in general, that is helpful if we rewrite things in the proper order. They also do some stuff where they're leaving some space. Okay. All right. Any questions? Okay. Folks, what I am going to do is I'm going to show you what your homework assignment is. There's one question that I'd like to just have a look at together. Okay. So this is your homework assignment. We're going to look at 6A together, and then we'll just spend a little bit of time in class here. You can work on your homework in class. 6A.
I feel like this is a trick question. It looks way too easy.
6a?
Yeah.
It's yeah, I mean it's simple. It's fairly straightforward. Yeah, it's not too bad. Is it a trick? I don't know if it's a trick. Okay, let me open up now the textbook. And I just want to talk, actually, just before we get there, question 4 has been assigned. Just like how we did rectangles, and you can do like area equals length times width. These with triangles would be the same, except the area of a triangle is 1/2 times base times height is what they usually say. So then for this one, you might start off by going 1/2, our base here is x plus 3y, and our height is x minus y. So I would suggest just leaving that 1/2 out front for now, maybe until you do everything else here. Okay. And just as a reminder, down here you have a trapezoid, right? For E, that one's assigned. And don't be too thrown off. What I'll say, this you don't actually need to know. This slant height you don't need to know. The area of a trapezoid is base times height. That's it. So you're going to have this base of 5x plus 1 and 3x minus 2. Rachel, everything okay? Rachel said she's super sad. How come?
That's a lot of triangles and rectangles and squares and trapezoids, and I hate that.
That's true. Although no rectangles. Look at that. No rectangles on this page.
That's good. Just triangles.
Yeah. All right. So moving on, we're looking at 6a. I wanted to look at this one together. Okay. It almost seems deceptively simple, but what we see is that we've got something cubed. And so what that means is that what we have is x plus 1 times x plus 1 times x plus 1. And this is why it's kind of ugly, because we've got like a whole bunch of stuff. What I'm going to focus on for now is this first part. Okay, I'm going to focus on, sorry, not this first part, these last two. So I'm going to write out, I like to just write out the x plus 1 again, but we're going to do our FOIL method here. So we're going x times x, that becomes x squared. X times 1 is x. 1 times x is x. And 1 times 1 is 1. So pretty straightforward multiplication that we're doing. And finally, not finally, but next, I'm going to do x plus 1. And I see that I've got two things in this orange part that can be combined. So that's x squared plus 2x plus 1. And now we can do our distribution again. So we've got x times x. X times x squared is x cubed. X times 2x will be 2x squared. And x times 1, that's x. Let's switch colors again. How about green? Got 1 times x squared, that's x squared. This is just everything times 1. So that's pretty straightforward. It's 2x plus 1. Finally, what's our last step here? We are not done.
Combining like terms.
Precisely, yes. So this x cubed, there is not another x cubed term. There's only the one. But there are two x squared here and here. So putting them together, we get plus 3x squared. We have an x here and a 2x here. Those can be combined to become 3x and then plus 1. Done. Right? All right. Folks,
Hold on.
Yes, hold on.
Where did the x squared come from?
Just this one here.
Yeah.
That came from, I believe, the 1 times x squared here. See that? I can highlight it in orange. That one. Yeah, okay. Folks, what I would like you to do for the next 10 minutes or so, maybe a little less, you can start working on your homework assignment, and then I do want to hear if you have some questions, okay? If you have some questions, you can send me a private message in chat. Where it says to everyone, you can change it to say to Kalen Bohr, and then you can say, I don't get number 2A or whatever. And maybe there's other people that are feeling the same way. I can show you a couple of things on the board here, okay? So yes, get started on your homework assignment, and I am available here to answer any questions, all right? And we'll just do that for 10 minutes or less.
Can I have all the homework pages again? I forgot to write them down.
Yeah. That's right here.